68 million tons. That's how much aluminum humanity consumes in just a single year. It's an enormous number that stretches across soda cans, window frames, and even the wings of giant airplanes. But have you ever wondered, how do we meet such massive demand without draining the Earth's resources? The answer lies in a groundbreaking innovation that transformed the entire industry: aluminum recycling. From collected scrap, aluminum is sorted, cleaned, melted down, and cast into new forms. Each recycling cycle not only saves up to 95% of the energy required to produce new aluminum, but also allows the metal to be reborn within 60 days, retaining its original quality every time. So do you think those small cans around you could be part of a green revolution? Don't miss this video, where you'll witness the extraordinary journey of aluminum, from discarded waste to polished products that return to everyday life, shining once more. Unlike many other metals that degrade in quality with each recycling cycle, aluminum can be reused infinitely without losing its original properties. This unique characteristic explains why nearly 75% of all aluminum ever produced is still in use today. And the United States has turned this advantage into industrial strength. Thanks to its advanced collection and smelting systems, recycled aluminum now accounts for over 1/3 of the country's annual supply, saving up to 95% of the energy required for primary production, enough to power millions of households each year. But the benefits aren't just economic. Aluminum recycling also plays a critical environmental role, reinforcing America's leadership. Every ton of recycled aluminum prevents up to 9 tons of CO2 emissions, which adds up to tens of millions of tons of greenhouse gases kept out of the atmosphere annually. This advantage is especially crucial as the U.S. ramps up its electric vehicle industry, wind power, and solar energy, all of which demand vast quantities of aluminum. The recycling journey begins with a step that may seem simple, but ultimately determines the efficiency of everything that follows: aluminum scrap collection. In the United States, the world's leader in aluminum recycling, this system operates on a massive scale, spanning everything from beverage can redemption points and municipal waste sorting centers to extensive industrial scrap buying networks. Each year, tens of millions of tons of aluminum are gathered from countless sources, creating a steady stream that fuels the recycling industry. What sets aluminum apart is its inherent economic value, even at the collection stage. A discarded aluminum can is worth many times more than a PET plastic bottle, giving both individuals and businesses a strong incentive to return aluminum into the production loop. This is why America consistently ranks among the top nations in aluminum recovery rates, securing a stable domestic supply of recycled material for its industries. From trucks loaded with beer cans and food trays to scrap yards glinting with metal, the collection stage is the true gateway to the metal's rebirth. The point where aluminum begins its journey back into the modern world, ready to return in a completely new form. From collection points across the country, convoys of trucks loaded with aluminum scrap steadily roll into massive staging yards. Each vehicle is weighed, logged, and then tilts its container to unload the cargo onto conveyor belts that feed into the storage area: beer cans from supermarkets, food trays from neighborhoods, and industrial aluminum scraps, all come together in towering piles of shimmering metal, resembling silver mountains. Right on site, technicians perform a quick preliminary inspection, swiftly flagging and rejecting any loads contaminated with excessive impurities or hazardous materials. The atmosphere in the yard is always high-paced. Thousands of tons of aluminum pour in daily, making this facility the true front line of the recycling process. The gateway where all incoming material is prepared for the next, more precise phase: detailed sorting. At the processing facility, streams of aluminum scrap are fed onto long, continuously moving conveyor belts. Optical sensors, acting as electronic eyes, scan thousands of fragments per second, identifying aluminum based on its distinctive color and light reflectivity. Immediately afterward, high-powered magnets remove any ferrous metals, while precision-timed air jets blast the aluminum away from plastics, paper, and lighter debris. Through multiple layers of separation, The once chaotic mix of waste gradually transforms into more uniform flows of aluminum, neatly clustered into glinting silver piles. From this point forward, the aluminum stream is now chemically consistent and tightly controlled, ready to advance deeper into the recycling process. Once separated, the aluminum scrap is fed into a massive shredding system. Conveyor belts constantly dump beer cans, food trays, and industrial scrap into counter-rotating steel rollers lined with sharp teeth. With intense crushing force, the metal shatters instantly, sending sharp metallic clatters echoing across the factory floor. In just a few revolutions, hundreds of kilograms of aluminum are pulled in and reduced to small fragments. The machine operates with precision, almost like it's pre-programmed. Rotating blades and crushing hammers assist the rollers, allowing the system to handle even thick, rigid aluminum parts. Under the glare of industrial lighting, streams of silver shards pour out continuously, cascading onto the lower belt like a sparkling stream. A vibrating screen system controls the output size, ensuring that all shredded aluminum is reduced to a consistent dimension, creating a stable, uniform feedstock for the next stage of processing. The shredded aluminum fragments are fed directly into industrial furnaces, the heart of the entire recycling process. Depending on the type of scrap and the desired end use, the plant may utilize reverberatory furnaces, rotary kilns, or electric arc furnaces. Each type is a sealed engineering system meticulously designed to control three critical parameters simultaneously: temperature, airflow, and material mixing rate. The internal temperature is maintained steadily between 660 degrees and 750 degrees, just enough to melt the aluminum without vaporizing valuable alloy components. Aluminum is loaded through the top hatch or a tilting chute, then constantly stirred by either mechanical paddles or controlled air injections. Some furnaces are equipped with heat recovery systems to maximize energy efficiency, while multi-stage filtration units treat exhaust gases to capture aluminum oxide dust and neutralize toxic emissions. Throughout the smelting process, thermal sensors and chemical analyzers operate continuously, acting as the system's senses, ensuring that every batch of molten aluminum meets precise technical specifications. The furnace is the climactic stage where everything converges: pressure, heat, chemical reactions, and mechanical systems all intertwine. A single misstep in control could turn an entire batch into waste. But when every element performs in harmony, the result is a stream of pure molten metal, ready to flow into the next phase of transformation. Even after the aluminum has fully melted, it still contains countless hidden impurities invisible to the naked eye. Aluminum oxides, furnace dust, paint residues, and even oils or greases left over from its previous life cycle. To eliminate these contaminants, the plant carries out a refining process directly within the furnace. The most common method is fluxing, the addition of a special flux agent into the molten aluminum. As it reacts, the flux bonds with impurities to form a light, floating dross layer on the surface. This layer is then skimmed off, either mechanically or manually, leaving behind cleaner, more refined metal. In more advanced systems, inert gases like argon or chlorine are injected at low pressure. These micro bubbles permeate the molten mass, trapping excess oxygen and hydrogen and carrying them to the surface for removal. The entire purification process runs under constant supervision by temperature sensors and control systems, ensuring that the molten aluminum reaches the necessary purity level required for the stages that follow. Once the molten aluminum reaches the desired purity, it is directed to the casting area, where it begins to take on its first defined physical form. This is the crucial transition from liquid to solid, from an amorphous metal mass to structured units that can be measured and transported. The aluminum is poured into molds made of steel, graphite, or specialized heat-resistant materials, depending on the product being formed. These could include vertical molds for ingots, horizontal molds for thick slabs, or continuous casting systems with water-cooled forced solidification. Pouring speed, mold temperature, and cooling intensity are all precisely calibrated. If poured too quickly, the aluminum can form gas pockets or surface cracks. If the mold is too cold, the metal may solidify unevenly, leading to internal structural flaws. Each parameter must be carefully balanced, much like keeping a steady stream flowing through a narrow gap. A slight deviation can distort the entire shape of the final product. In many modern facilities, the casting process is fully automated. Sensors continuously monitor pouring height, cooling rate, and surface temperature. Yet in some semi-manual lines, skilled workers still control the flow, a task requiring sharp instincts and split-second precision. Once the aluminum solidifies inside the mold, a hydraulic system gently pushes from the bottom, releasing the solid metal from the steel mold walls. Mechanical clamps grip the heavy ingot, often weighing dozens of kilograms, lifting it from the casting trough and placing it onto a parallel steel conveyor. The sound of metal scraping echoes throughout the foundry, while the surface of each ingot still glows faintly red from residual heat. One by one, the ingots are extracted in sync with the machinery, lined up neatly on the moving belt. Sensors quickly scan each piece, checking shape and dimensions to ensure no deformation occurred during demolding. From the casting area, rows of solid aluminum ingots begin their steady journey forward, perfectly aligned like metal bricks, marking the completion of a full production cycle inside the furnace. After being removed from the mold, the aluminum ingots are transferred into a preheating furnace to soften them, bringing the metal to the ideal condition for rolling. Once ready, each ingot passes through a set of counter-rotating steel rollers, where tremendous pressure flattens and elongates the aluminum block. This process is repeated across multiple roller stands, with the gap between each pair gradually decreasing. As a result, an ingot that originally measures several inches thick, often over 8 to 10 inches, is progressively transformed into a thin, uniform metal sheet. A fine water mist cooling system keeps the surface stable, preventing cracks or warping caused by excess heat. By the final stage, the sheet reaches its target thickness, often down to a few hundredths of an inch, and is guided forward into a continuous strip, then tightly wound into large coils. These standard semi-finished coils can now move on to further processing, such as cold rolling, cutting, or stamping, depending on their intended use. Among the countless products made from recycled metal, the aluminum can stands as the clearest proof of recycling's power, returning to store shelves just weeks later in an entirely new form. From massive aluminum coils, the can forming process begins by stamping thin aluminum sheets into flat, round discs known as blanks. These blanks are fed into a deep drawing press, where, in a single stroke, the metal is stretched into a small cup shape with thin walls and a flat bottom. The aluminum cup then passes through a series of ironing dies, with each stage making the can taller and its walls thinner until it reaches its final dimensions. The top edge of the can is slightly necked in to prepare for the lid attachment. Inside the can, a microscopic polymer coating is sprayed to prevent the aluminum from coming into direct contact with the beverage, ensuring both safety and flavor retention. Finally, the exterior surface is decorated using high-speed rotogravure printing, enabling thousands of cans per minute to be finished with precise labels. The completed cans are then stacked in batches, ready to enter the filling and sealing line. Once they leave the production line, aluminum cans appear everywhere, stacked on supermarket shelves, chilled in cafe ice buckets, popped open at lively parties, or quietly shared at family gatherings. Every day, hundreds of millions of cans are consumed worldwide, woven into the rhythm of modern life, from quick refreshment breaks to moments of shared connection. But the value of an aluminum can doesn't end the moment it's used. Once empty, it faces a critical crossroads, discarded as waste or placed in the right recycling bin, unlocking its potential for near-infinite rebirth. In countries that operate deposit return systems, more than 80% of cans are recovered and recycled into new products within just a few weeks. In contrast, cans tossed into household trash become an environmental burden, despite being one of the most sustainable materials ever created. Ultimately, it's the consumer's choice that determines the can's fate. Every time you drop a can into a recycling bin, it's more than a small act. It's a vital link in keeping the green cycle alive. ensuring that aluminum continues its endless journey instead of ending up in a landfill. We've just witnessed the remarkable journey of aluminum's rebirth, a closed-loop cycle that never truly ends. From what once seemed like worthless scrap, aluminum is reborn endlessly, returning to our lives in countless forms, from soda cans and window frames to aircraft components. This circular journey isn't just a triumph of technology, it's also a reflection of the choices we make every day. That can in your hand, it can end up as waste, or it can return to the production line and be reborn as something new in just a few weeks. The decision lies in a single simple act, placing it in the right recycling bin. So what will you choose? Let the can's life end abruptly, or help it continue its endless journey, contributing to a greener future for us all? If this video gave you a new perspective on the value of aluminum recycling, give it a like, share your thoughts in the comments, and don't forget to subscribe to follow more fascinating production journeys in our upcoming videos.